In this section, we're going to study how to obtain information from or about the graph of a function. So now let's look at an example, okay? Let f, which is the function name, okay, be the function whose graph is given in the figure 15, which is the next slide. I'm going to move to the next slide, just let you glance the graph, okay? This is the graph of this example, look like a W-shaped, okay? Okay, let me go back to the previous slides and then explain what this graph is about. Okay, the graph of function might represent the distance y that the bob of a pendulum is from its at-rest position at the time x. Negative value of y means that pendulum is to the left-hand side of the at-rest position. The positive value of y means the pendulum is to the right-hand side of the at-rest position. All right, so just based on this description, I want to go to the graph, just show you, okay, what that really means. All right, so let me just draw a simple pendulum, okay, try to help you understand. Okay, this is the rest position, okay, if this is the bob. And then looks like the starting one, okay, because that's a positive value, according to the description of the problem, it says a positive means the pendulum is on the right-hand side of the rest position, right? This is a rest position, okay, so right-hand side. So it starts from here, okay, and then release the pendulum. So due to the gravity, it will come back to the rest position, okay, in this way. So that refers the graph, this part, okay? And then after, to the rest position, it will keep moving, okay, until to the most left-hand side, when the energy is become a zero and then stopped. Okay, that's the most left-hand side point. So that refers to the graph, this part, reach to the farthest position of the rest position, right? And then the pendulum, due to gravity, again, is come back, okay, to the rest position. So that's the part come back to the rest position. And then it keep moving to the right-hand side again. So now going this side, okay, go back to the initial place and then come back to the rest position. So here, go this way, okay, again to the rest position, and then move to the left-hand side to the most farthest position, okay, and then come back to the rest position. So come back and then go back to the initial position. Okay, that's what this graph is represent. Okay, I hope that help you understand this problem a little bit better. All right. So I really don't want to this much drawing because I just want to get rid of the one I just draw. Okay, I'm gonna get out of here and then back again. Okay. All right. Sorry about that. All right, so now let's see what we're trying to find out from this graph. Okay, we're trying to first evaluate function when x equal to 0, when x equals 3 pi over 2, and when x equals 3 pi. Okay, we want to evaluate function f of x at this three particular position. Okay, what is the corresponding y? And then we want to find the domain of the function. We want to find the range of the function. And then we want to identify all the intercepts. Okay, and the next question asks how many times does the line y equals 2 intercepts the graph? Okay, later we will see how many times. And then the next question asks you for what values of x does the function equals -4. The last question asks you for what value of x is f of x greater than 0. Okay, I hope you kind of remember those questions. If not, you can always, come back to this slide to read the question again. All right, now let's look at the graph and then identify those information from the graph. All right. Okay, so come back to the graph. So first one, we want to evaluate function, right? We're looking for, okay, put it here, A. We want to find f of 0 equals what? And then we want to find f of 3 pi over 2 equals what? And then f of 3 pi equals what? All right. So in order to evaluate function from the graph, first of all, you need to understand, how to make this graph, which is this blue curves, okay? Where this graph coming from? Actually, every point on the graph of a function, okay, every point, this graph composed by 100 millions of points, okay? When those points are so close to each other, and then you visualize it as continuous, okay, which is smooth curve, but actually they composed by many, many, many points. And each point represent a solution of a function, okay, and this function is represent the distance, okay, the y is the distance from the rest position, okay, x represent the time. All right, so by understanding how the graph is made of, and then we can, looking for the value of the function. So f of 0, okay, when x equals to 0, what is the corresponding y? So first we have to look at when x equals to 0, what is the point on the graph? Okay, so when x equals 0, that's x equals to 0, and then if you draw the vertical line, for x equal to 0, you see this is the point on the graph, right? And then we're looking for the y coordinates, right? Because f of x, it is the same as y. So the value of function actually is the corresponding y coordinates of the graph of the function, okay? So when x equals 0, y equals 4. That's how we evaluate f of 0. Okay, we're looking for this point on the graph and then read the y coordinates from the point. Sometimes the coordinates is not given like this, 0, 4, okay? But you can, as long as you identify this point, you can easily read the coordinates from the graph, right? Which is 0, 4. All right, let's try next one, f of 3 pi over 2. So we're looking for when x equals to 3 pi over 2, what is the point on the graph? Okay, when x equals 3 pi over 2, right here, what is the corresponding y coordinates? 0, right? We're looking for when x equals 3 pi over 2, what is the point on the graph? And then rate this point's y coordinates. That's how we evaluate the function from the graph. All right, I'm sorry. And then the next one, f of 3 pi. So can you find where is the point when x equals to 3 pi? When x equals to 3 pi, right, that refers to this point on the graph. So read the y coordinates of this point. So when x equals to 3 pi, y equals -4. Okay, that's how we get the answer for question A. All right, now let's try B. B is asked us find the domain of the function. So that's about the definition of the domain. Let's recall, what is the definition of the domain? Do you still remember? Is all the value of input x, right? All about x. So what are all the x? X refers to the horizontal direction. So actually on the graph, we're looking for the most left point. Okay, the point on the most left-hand side and the point on the most right-hand side. Most left point or most right point. Okay, so on the graph, can you find which point is the most left point? Which point is the most right point? Can you find it? I don't know. Can I change the color of my pencil? All right, I'm just circle it. Okay, this is the most left-hand side point. This is the most right-hand side point. Does that make sense to you? See, any other point on the blue line, that will be on the right hand side of this, right? So this is the most left hand side. And then for this point, every blue point will be on the left hand side of this point. That's why this is the most right hand side. And then read the x coordinates from these 2 points, because domain is all about x. Okay, so the domain, okay, let me write. You can write as a set notation, which is variable name is x, and then what's the condition? It's 0, right? Less than or equals x, less than or equals 4 pi. So why have an equal sign? Because these two are solid point, so it should include in the boundary. Okay. If you want to write into interval notation, that's fine too. It's from 0 to 4 pi. So any number between 0 to 4 pi, that will be the domain. That will be all the x, because the graph is continuous, right? So every point you need to look for the x coordinates on the number line. So actually that's all the points on the number line from here to here. All right. So that's how to find the domain. Find the range. Range is all about y's, remember? All the value of y's. So this time we're looking for the lowest point on the graph and the highest point on the graph, because that's the vertical direction this time, right? Domain is the horizontal direction on the graph, and then looking for the range, we're looking for the vertical direction because it's about y. So which point is the most lowest point on the graph? From your visualization, we will say, right, these 2 points are the most lowest point, right? So what is the y coordinates? It's all about y, remember? So that's from -4. And then what is the highest point? This point, and then this point, right? These 3. So what is the y coordinates? 4, right? So from -4 to +4. Again, they are all the solid points, so inclusive. Okay, if you want to write a set notation, that's variable name is y, and then vertical bar, and then y value is from -4 to +4. Okay, that's how to write the range in the set notation. Okay, that's answers B and C. Okay, that's the question C. And then D asks us find all the intercepts. Find intercepts is easy, right? We're just looking for graph intercept with x-axis and a y-axis. So we have one y-intercept is right here, right? This is a y-intercept, so that's 0, 4. Right? That's the D part. Okay? And then x-intercept we have how many? 1, 2, 3, 4, right? The graph intercept with x-axis 4 times, and then you can read the coordinates from the graph, which is pi over 2, 0, and then 3 pi over 2, 0, and then 5 pi over 2, 0, the last one, 7 pi over 2, 0. Right? So total, we have 5 intercepts, 1 y-intercept, 4 x-intercepts. All right, that's the question D we answered already. Question E is asking us how many times line y equals 2 intercepts graph. So first of all, you need to know y equals 2 refers what kind of line. Remember in the previous chapter or chapter 1, we learned about the graph of a line, right? Which is y equals 2 refers to what kind of line? Horizontal line, right? So where is y equals 2? I draw the dashed line. Okay, it's a horizontal line right here. So now let's see how many times intercept with the graph. 1 time, 2 times, 3 times, 4 times. Okay, so answer question E. The graph intercepts with the line y equals 2 4 times. Okay, and then question F. what value of x does f of x equals -4? So now we're looking for y equals -4. And then you can draw y equals -2 line. That's another horizontal line, right? So actually you can see those 2 points from the graph. When y equals -4, x equals what? Only 2 points satisfying this condition, right? So when x equals pi and when x equals 3 pi, y equals -4. Okay, that refers to only 2 points. And then the last question is, I will say that's the most difficult one. Okay, question G is asked for what values of x is function f of x greater than 0. So f of x greater than 0, that means what? Y coordinates is greater than 0, right? So what is the y coordinates equals 0? The x-axis right here, right? That's y equal to 0. Anything above the x-axis, that will be what? That will be f of x greater than 0, right? So let's see what part of the graph is above x-axis. Okay, so that will be from this point. Okay, I'm drawing over here. This point start from here to here. Okay, this part. Okay, I can change the color from here to here. This is a y greater than 0. So how to write this part of the point in terms of interval notation? That's from, I'm right here. That's from 0, right? This is solid point to pi over 2, right? What value of x? So we're looking for the x coordinates of those points. This point between, right? This is a part of the graph. So from 0 to pi over 2. Because greater than 0, this is the point equal to 0. So pi over 2 is not included in the answer. And then what else is part of the graph above x-axis? Okay, look at this part. This is the above x, right? From here to here. Okay, so this point, what are x coordinates? That's 3 pi over 2, right? And then what about this point? 5 pi over 2, right? And these 2 points, both y equal to 0. So we want the y greater than 0. So this 2 point is not included in the solution, right? And the last part on the graph above x-axis is this part. So this point is 7 pi over 2, and then until 4 pi, right? 4 pi is a solid point, so here is square brackets. 7 pi over 2, this point refers y equal to 0. We want the y greater than 0, so this point is not included. So the answer is refers to the 3 line or 3 curve segment, okay, on the graph. That's why we use the 3 interval notation to represent. And all of them are the answers, so we're gonna use union symbol. That means all of it, okay? This and this and this, all of them combine, okay? This U, this is the symbol represent the union, okay? Combine all together. All right, so that's the answer of question G. Okay, this is a very complicated problem. I hope after you watch the video, you better understand it. Okay? So this is a solution book is given. You can read through it. All right?